For years, one idea ruled this industry. Farm work was too messy, too uneven, and too alive for a robot to handle. A field is not a factory floor. Soil changes, light changes, dust hides danger. Crops do not stand in perfect rows forever. Weather can flip a plan in hours. The common view was simple. Big tractors could get stronger, smarter, and more connected, but they would still need a person in the seat. That belief ran straight into a labor problem that would not wait. According to the United States Department of Agriculture, farm job openings rose by 42% in 2021 through 2022 because of labor shortages. At the same time, the pressure to keep output high kept growing. That is the crisis behind this machine. Not a concept sketch, not a lab toy. A full-size American field tractor built to work at the scale of modern farming. By the end of this video, you'll know why this works and how to apply it with what you already have. The machine at the center of that shift is an autonomous tractor built for precision farming tasks. Its purpose is direct: increase efficiency in crop production and reduce the damage caused by labor shortages. The way it does that is not magic. It uses artificial intelligence, sensors, and GPS systems so it can carry out farm work with minimal human input. That alone would be enough to get attention. What made people stop and stare was the scale. John Deere is the company pushing this machine into the spotlight. Deere has long been one of the biggest names in American agricultural machinery, and the company has spent years moving from heavy iron into software, cameras, machine vision, and machine learning. A key step came in 2017 when John Deere acquired Blue River Technology. That deal gave Deere deeper skill in artificial intelligence for agriculture. One of the names linked to that shift is Jorge Araud, co-founder of Blue River Technology. His view was blunt. Technology in agriculture is no longer just a luxury, it's a necessity for sustainable farming. That line matters because it cuts against an older idea in farming. The old idea said automation was a nice extra. Useful, maybe, but optional. The newer case is harder. If labor is tight and timing is everything, automation stops looking like a luxury and starts looking like a way to keep the work moving. The wider market points in the same direction. Fortune Business Insights valued the global agricultural machinery market at about $177.4 billion in 2021 and projected it to reach $265.8 billion by 2028, growing at a compound annual growth rate of 6.1%. Research and Markets projected that autonomous tractor sales could rise to more than 56,000 units annually by 2025. Those are not hobby numbers. They show where manufacturers believe the money and demand are heading. Still, big forecasts do not impress engineers by themselves. Machines do. Steel does. Numbers on the machine do. This tractor drew attention because it was described as Colossal, a high-tech autonomous tractor designed for real field tasks, not a stripped-down test rig. It sits inside a new class of farm equipment where brute force and computer vision live in the same body. By 2020, interest in autonomous tractors and precision farming had started rising across the industry. By 2022, fully autonomous tractors were being tested on farms across the United States, and interest and investment both increased. By 2023, major agricultural expos were showing off the latest versions to buyers. As of October 2023, Deere and other manufacturers were still actively developing and promoting autonomous tractors, and farmers had started integrating them into daily practice to deal with labor shortages and raise productivity. That timeline matters because it shows this did not appear overnight. The public shock comes late. The engineering buildup took years. What changed the mood was proof that autonomy was moving from trial to field use. Recent updates reported by AgFunder Network partners said autonomous tractors had improved software for better efficiency and user experience. That sounds small until you think about what software means on a machine like this. Software decides how cameras read a pass through the field. It shapes route planning. It handles how a machine reacts when conditions shift. In a system built around minimal human intervention, software is not a side feature. It is the operating mind. And yet the real reason this machine stunned people is that it attacked the strongest argument against field autonomy. The mainstream consensus was that real fields are too chaotic. That is the accepted belief the machine challenges. A robot can repeat a task on a closed route. A robot can move in a clean warehouse. Farming is different. The machine has to deal with uneven terrain, changing crop conditions, dust, glare, and all the random surprises of outdoor work. Critics used that chaos as proof that autonomy would stay limited. The counter-argument is now built into the machine itself. Deere's approach combines AI, sensors, and GPS to let the tractor do precision work with little direct input. That does not mean every job on every farm is solved. It does mean the old claim that no robot could handle the field is no longer safe. Not when actual farms are already integrating these machines. There is another side to this story, and it should be said clearly. Supporters of automation say these systems can ease labor shortages, improve efficiency, and make farm work more precise. Critics raise a different set of worries. They talk about job loss in farming. They question reliability. They point to maintenance costs on advanced machinery. They also raise concerns about data privacy and who controls the farm data these machines generate. Those objections are not fringe. They are part of the real debate around autonomous equipment. That debate gets sharper because these machines are not cheap experiments. They are major capital assets. When a farmer commits to a large autonomous platform, the decision reaches beyond horsepower. It touches repair, software support, uptime, data flow, and trust. A machine can promise lower operating hours and better output efficiency, and some farmers have reported exactly that from autonomous tractor use. But if the machine stops during a narrow planting or tillage window, the cost of failure is not abstract. It is measured in lost time when time matters most. That is why Deere's effort has involved more than one company building alone. The development of these large machines often includes work with tech firms, universities, and agricultural organizations so the technology fits real farm needs. That kind of cooperation matters because autonomy in agriculture is not only a hardware problem, it is a sensing problem, a software problem, and a field use problem all at once. There is also a simple reason this story grabbed attention outside agriculture. The machine looks like a piece of industrial science fiction dropped into dirt. It is the meeting point of old power and new control. Farming has always relied on scale. Bigger fields pushed bigger implements. Bigger implements pushed bigger tractors. What changed is that the person in the cab is no longer the only possible control system. That shift is bigger than one company. The American Farm Bureau Federation, which represents farmers' interests, has at times commented on technological advances in agriculture. That tells you automation is no longer a side conversation. It sits in the center of how the industry talks about labor, output, and the next stage of field work. There is a common belief that farm technology mainly helps giant operations and leaves everyone else behind. The evidence in the research is narrower than that claim. What it does show is that farmers have started integrating autonomous tractors to answer labor shortages and increase productivity. It also shows that users have reported reduced operating hours and better output efficiency. That does not prove every farm wins in the same way. It does show that the value case is already being tested in real conditions, not only in sales decks. The machine's use of precision farming matters here. Precision farming means using data and control systems to target work more accurately. In plain language, the tractor is not just moving through a field. It is reading, adjusting, and carrying out tasks with more exact control than a blind pass. AI helps with those decisions. Sensors gather what the machine sees around it. GPS anchors the machine's position. Put together, those tools aim to reduce wasted motion and improve how each pass is done. That challenge to the old view is why the machine feels shocking. Not because tractors have never changed before, they always have. The shock comes from what autonomy asks people to accept. It asks them to believe that a machine can now handle enough of the chaos to be trusted outside a demo. The industry once treated that as the line that could not be crossed. The race is also wider than Deere. Other manufacturers are developing autonomous tractors too, and that matters because competition forces these systems to improve. The rise of autonomous farm machines since 2020 has not been a one-brand story. It has been an industry-wide push tied to labor pressure and precision agriculture. Seen from that angle, the large machine is not only a tractor, it is a signal flare for where farm engineering is headed. Hardware is still king in one sense. You still need weight, traction, power, and endurance to do hard field work. But hardware alone no longer wins. The next layer is machine perception. Can the tractor understand the space around it well enough to work with minimal intervention? Can it stay useful when conditions change? Can it produce enough trust for a farmer to give up direct control? That trust is the hard part. It is easier to build power than confidence. A giant machine already impresses people. Autonomy has to earn belief over time. That is why the research timeline matters so much. 2020 brought rising interest. 2022 brought farm testing. 2023 brought public demonstrations at major expos. By October 2023, real integration was underway. Each stage moved autonomy one step closer to normal. The larger market numbers explain why the push will not slow soon. A global agricultural machinery market projected to rise from $177.4 billion in 2021 to $265.8 billion by 2028 tells manufacturers where future demand may go. A projection of more than 56,000 autonomous tractors sold annually by 2025 tells them the autonomous segment is not a side bet. Those numbers come from Fortune Business Insights and Research and Markets, and they show why heavy investment in autonomy continues. Still, numbers from market analysts are not the same as field proof. The field proof has to come from work completed, hours saved, and output maintained. That is where farmer experience starts to matter more than headlines. The research notes that some farmers using autonomous tractors have reported lower operating hours and better output efficiency. That does not answer every concern about reliability or maintenance costs. It does show that the value is not only theoretical. The strongest challenge to the machine comes from the critics who focus on reliability and control. A conventional tractor can fail too, but its systems are familiar to many operators. An autonomous tractor adds layers of sensors, computing, and software dependence. That raises the fear that a simple mechanical problem can become a harder systems problem. It also raises the question of who controls the data produced by the machine. In agriculture, field data is not trivial. It can shape decisions, input use, and planning. Control over that data is part of control over the farm. Those concerns keep this from being a simple victory story. The machine is impressive, but the change it represents is bigger than horsepower. It asks whether farming will trust computer vision and AI with work once thought too unpredictable to automate. It asks whether efficiency gains will outweigh cost, repair, and data concerns. It asks whether the labor shortage is strong enough to force a new way of working. Right now, the evidence says the push is real. Deere is advancing autonomous tractors. Farmers are beginning to use them. Software is improving. The market is expanding. The old consensus that field chaos blocks autonomy has been challenged by actual machines operating in actual agriculture. And that may be the most surprising part of all. The machine did not shock people because it looked futuristic. Farm equipment has looked extreme for a long time. It shocked people because it attacked a problem many thought had no clean answer. Labor shortages were rising, precision demands were rising. The work still had to get done. The answer now being tested across American farming is not only a bigger tractor, it is a tractor that sees, thinks, and works with less human input than the industry once thought possible. This is the moment when farm machinery stops being judged only by how much it can pull and starts being judged by how much it can understand. That is the real leap. Steel and size got it noticed. Artificial intelligence, sensors, and GPS are what changed the argument. So when people call this new American farm machine shocking, they are reacting to more than scale. They are reacting to the collapse of an old limit. The field was supposed to be too chaotic. The labor shortage was supposed to be too hard to solve. The operator seat was supposed to stay occupied. John Deere and its peers are now testing a different answer in full view of the industry. Not perfect, not free from debate, not finished, but real enough that the conversation has changed. The biggest machine in the field is no longer only a source of power, it is becoming a source of judgment. And for an industry built on timing, soil, weather, and risk, that might be the boldest change of all.